Derek, what are you doing?
It's time to wake up. Where's Derek? Why isn't Derek there before?
I don't know.
Have you seen Derek?
No, I have not.
Hey guys.
Derek, where you been, man?
Oh, I got a malt lesson back.
You guys ready to do this? Let's go.
Firepower combined. ECE 14.8. Let's do this.
Pacific Northwest National Laboratory, a proud sponsor of ECE Team 14.8. Go.
Welcome to Team ECE 14.8 News. I'm your host, Derek Gabriello. I'm substituting for William Hindeshot. He's out with a head cold, unfortunately. So today we'll talk to you about Project Scope Framework. Now, what exactly does that mean? Well, see, P&L gave us this fancy framework for us to build a model with. And so now what we have to do is we have to go through step by step, and we have to create ideas for each of these. And then along the way, we have to sort of say, does this work? Does this help us? How can we critique it? How can we make it better? Questions, questions, questions. So to start off, we're modeling an inverter. We got this idea from our faculty advisor, Dr. Louie, brilliant man, get to know him. And we said, well, let's model this inverter. Let's see what we can do with it. And we came up with a mission statement of, let's develop a mathematical model of the power efficiency of this inverter under various loads. And all of us were just like, brilliant, this is great. So that's exactly what we're doing. And we've, met some various roadblocks, like how are we going to test it? And so we've been going through many tests, and it's been working out. And we're getting closer and closer to a more refined project. And I think at the end of the day, we're going to have a wonderful model and a wonderful report for P&L. And now, let's go to our lab expert reporter, Kyle Shoemaker, and check in with our lab setup. Kyle?
Alright, so I'll take you through our lab setup real quick. What we have here is a 12-volt DC car battery. We have a square wave inverter, which will take the 12 volts DC input from the battery and convert it to 220 volts square wave AC. And we have a resistive load here. So what we're going to do is we're going to take the output from the square wave inverter and we're going to put it across this purely resistive load. And we're going to use the oscilloscope and this current clamp and this digital multimeter, and we are going to make measurements with various loads to determine the power efficiency of this square wave inverter. Now I'm going to connect this battery. Let's see if it works.
Well, we'll have to get that fixed for next time. Well, that's all for the update. We'll see you guys next week. What's that say? I can't read that. There's no words on it. It doesn't, no, we'll do it live. I'm done.